and welcome to another episode of Beyond the Basics from the Safety and Numbers Math Teaching channel. I'm your hostess, Sheila Hansen. In this episode, we will add positive and negative numbers. And I say positive and negative numbers instead of integers because it actually works with all positive and negative numbers, including ones with decimals and fractions. So yes, it works with integers, but also all the numbers in between. And to do that, we're going to start out by discussing what it means to add. In order to understand this concept, you need to really understand what it means to add. Then we'll be showing models of adding on a number line and adding by combining things. And then we're going to talk about the rules for adding positive and negative numbers. First of all, addition. When things get complicated, so like when you throw some negatives or fractions or variables in there, then you have to really understand that addition means to put things together. When you put things together that are alike, you get more of the same. So that just makes sense. If I have 3 B's and I add more B's to it, then I'm going to have more B's. If you add things that are unalike, and in this case we're talking about the positive or the negative sign, then you get things that end up canceling out and you end up with less than what you have. That's where a lot of people get confused when it comes to adding integers or adding positive and negative numbers. So here's our vertical number line model. And sorry, the numbers on my vertical number line, I want the positives to be red and the negatives to be blue, but I couldn't find one that was like that. We are going to be representing positives as red and negatives with blue, and we'll just roll with it. So first thing we're going to look at is adding two numbers that are positive, such as 2 plus 3, and you already know that 2 plus 3 is 5. So we start with the number 2, and it's represented by going up 2. And then we add 3, which means we go up 3 more, starting from 2. And we end at the number 5. That's why 2 plus 3 is 5. So the length of your arrow shows you what the number is. The first arrow is 2 units long, the second arrow is 3 units long. What if you add two negative numbers, like negative 2 plus negative 3? I'll tell you right now it's negative 5, and here's why. The negative 2 is represented by an arrow going down. So you go down 2, and then you go down 3 more. So those are combining things that are alike. You combine negatives with negatives, you end up with more negatives. You combine positives with positives, you end up with more positives. What happens when you add a positive and a negative together? So you're adding things that are not alike. Here's what I was talking about when you get things that cancel out. So what if I had negative 2 plus 3? What would that equal? Well, let's take a look at the number line again. Negative 2 is represented with an arrow going down. Positive 3 is represented with an arrow going up. But it starts where the other arrow ended. So it starts at negative 2 and goes up 3 units. It doesn't go up to the number 3, but that arrow is 3 units tall. You end up at positive 1. So some of your numbers canceled out because you know that 2 and 3 make 5. But in this case, negative 2 and negative 3 only made 1. That's because the negative 2 and some of the positives will end up canceling out. So let's write this down in your notebook. Now we're going to look at the model of combining things, because as I said before, adding is putting things together. We're going to use the idea of having a bubbling cauldron of soup, or bubbling pot of soup. The little circles in there, like those are the bubbles in the pot, so pretend like you got some soup going on in there. We are going to add some fire, that's our positives, and then some ice, that's our negatives. If you think about it, what would adding fire to the pot due to the temperature of the pot? That's right, it's going to raise it. If I added ice to it, what would happen to the temperature of the pot? That's right, it's going to go down. So this is what we're looking at. Let's take our first example. 2 plus 3 is 5. Same examples as before. I like to stick with the simple ones because it's easier in your head to imagine. So the 2 is positive. So fire is positive because it's hotter. So I'm going to add 2 fires to my soup. Then we got to look at the plus 3. So now I add 3 more fires to the soup. And I end up with a total of 5 fires. So if the soup started out at a flat 0 degree temperature, and I added 2 fires and then 3 fires, it's now at a 5 degree temperature. Now let's look at the second example. -2 plus -3 is -5. So again, our soup starts out at a flat 0 temperature. We have a -2, what we're starting out with, so I'm going to add 2 ice to the temperature, which means the temperature is going to go down 2. Then I'm going to add 3 more ice. So the temperature is going to go down 3 more, meaning that my temperature there, you can see the 5 little ices floating in the soup. My temperature is now 5 degrees below 0 because it started at 0. So if you add only fire, your temperature raises. If you add only ice, your temperature goes down. What happens if you add both fire and ice, such as 2 plus -3? The 2 is positive, so I start by adding 2 fire. The 3 is negative, so then I add to our soup 3 negatives. Now, something strange happens when you add fire and ice. The ice and fire cancel each other out. They don't change the temperature at all. But you notice I have 1 ice left, meaning my answer is -1 because that's the only thing still floating in the pot. So the ice put the fire out and the fire melted the ice, so they're both gone. So in problems like this, when you're adding fire and ice together, whichever one you have more of, that's going to be the result of the temperature change. So if I add more ice than I do fire, my temperature is going to be a negative temperature. If I add more fire than I do ice, my temperature is going to be positive. If I add more positives than I do negatives, my answer is negative. If I add more negatives than positives, then my answer will be negative. So the answer will be whatever is most. Sort of like in the arrow, the sign on the answer will be whichever arrow was longer. If both are the same, then you're going to have, like if you add only ice to the pot of soup, your temperature will be negative because it will go down. If you add only fire, your temperature will be positive because it goes up. And some people say, well, what about a double negative equals a positive? So wouldn't -2 plus -3 be +5 because they're both negatives? Double negative equals a positive is a far, far misunderstood concept. And it does not apply in this case. We will get to a time when it does apply, and that's going to come when we are subtracting negatives and when we are multiplying negatives, but it does not happen here. So let's write this down in your notebook. I'm still on the same spot, I'm just writing in the space that's to the right of your original notes. There are a couple of rules that can make this easier to remember. Understanding the concept also makes it memorable. If I add positives to positives, I'm going to end up with more positives. If I add negatives to negatives, I'm going to end up with more negatives. If I add positives and negatives together, I'm going to end up with some things canceling out, which ends up meaning you're going to have to subtract because they take away from each other. Here's the first rule that can help you remember these. When adding 2 numbers with the same sign, add and keep the sign the same. Not like stop signs or anything, but rather positive signs and negative signs. So if I add 2 positives, that means both numbers I'm adding have a positive sign. If I add 2 negatives, that means both numbers I'm adding have a negative sign. If both numbers I'm adding have a positive sign, then my answer is going to be positive. If both numbers that I'm adding have a negative sign, then my answer is going to be negative. When you're adding 2 numbers that have different signs, you're going to subtract and keep the sign of the most. If I'm adding a positive to a negative or a negative to a positive, if I end up having more positives than negatives, then my answer will be positive. If I end up having more negatives than positives, then my answer will be negative. Let's write this in our notebooks. Same example problems as before. This can get kind of confusing if you overthink it. So practice, practice, practice. 3 plus 7. Both of those are positive, so I'm going to add them and keep my answer positive. 3 plus 7 is 10, so it's positive 10. What about negative 3 plus negative 7? Well, I'm adding negatives to negatives, so they both are negative. They have the same sign. I will add them and I'll keep my answer negative. 3 negatives plus 7 negatives, you have 10 negatives. What about negative 3 plus 7? They have a different sign. Your 3 has a negative sign, your 7 is positive. Different signs subtract. 7 minus 3 is 4. Which one do I have more of? Positive or negative? On this one, I have more positives. So my answer is going to be positive 4. What if I had 3 plus negative 7? That's different signs, so I will subtract. 7 minus 3 is still 4, but this time I have more negatives than I do positives. So my answer is negative 4. Here's a few others. See if you can get them. How'd you do? Keep practicing this skill. The key to learning any new skill is to do it over and over and over again a lot. Think about how you learned how to walk, or you probably don't remember that. Think about how a child learns how to walk. You've seen it. Think about how you learn to ride your bike. Think about how you learn to write, how you learn to do anything, how you've memorized songs, how you've memorized pathways in a game. Because you've done it over and over and over again. Learning mathematics works very similar. You do it over and over and over again because it helps you to learn the concept. It helps you to remember it. And for technical speak, it is creating a neural pathway in your brain. And the more you practice that neural pathway, the deeper it becomes, the easier it is to use. So I use the example of if I have a field of grass out in front of my house, and I walk from point A to point B every day for years, there's going to be a trail worn where I walk, so long as I walk the exact same way. That grass gets worn down, the dirt gets worn down, and pretty soon it's pretty easy to see where I've been. Mind works kind of the same way. The more you practice something, the easier it is to remember. Thanks for watching, and I'll see you next time when we look at subtracting positives and negatives.